Hey guys, welcome to class. All right, so for some of you this is a new experience, and that's perfectly fine. So let's go over the rules really quickly. The way this works is I'm going to be teaching the lesson from my house. You're going to respond to the video as if I'm standing right there teaching right in front of you. If I ask you to give me a thumbs up, you give me a thumbs up. If I ask you to answer a question, you answer a question. You follow the instructions as if I'm asking it to you face to face. So let's begin our lesson. For the past few weeks, we've been learning about energy. Chemical energy, mechanical energy, electromagnetism, thermal energy, sound energy. This week, we're going to be talking about electrical energy. So that leads me to my first experiment. What I want you guys to do is I want you to look around. I'm going to give you about 15 to 20 seconds to look around and find 5 things in the classroom that use electrical energy. Now that can be things that store energy, electrical energy. That can be things that use electrical energy. That could be things that use power outlets on the wall. I want you to look for something that uses electrical energy. I'm going to give you 10 to 15 seconds. Go for it. Look around. When you're finished, give me a thumbs up. Let me know that you guys are done. I see some people looking at the projector. That's an obvious one. My computer's a good one. 5 seconds. Okay, perfect. Now, take a walk with me. We're going to walk around my house. We're going to look for some things that have to do with electrical energy. And if you spot them out, just call them out. That's perfectly fine. Ah, my refrigerator. Okay. My microwave. That's a good one. Ah, my toaster. Good call. Good. My coffee maker. Ooh, this one's a sneaky little one. This guy uses a light bulb. And here's the power cord for the electricity. Okay. Oh, I see one. I see one. Everybody should know this one. My charger for the iPad. Oh, what is this? Ah, my computer charger. That's a good one. There's an iron on my table. Good. Okay. So it's easy to see that electricity is all around us. So here's the thing. Today we're going to be making our own circuits. And I'm going to ask you to draw, video record, and tape yourself making your own electrical circuit. But first, we have to learn, how does electricity work? So let's take a look. All right, this is your normal average everyday can, and this is a balloon. Now what I'm going to show you is this. I'm going to show you how I can take the electrical energy from here and attract this can with that electrical energy. I'll lay the can right here. As you can see, it's not going to roll anywhere. Now I'm going to take my balloon and rub it in my hair really good. Get it charged with some good electricity. Okay? Now watch what happens. Now, I know some of you think that's kind of crazy. However, what we're going to do is I'm going to give you a chance to do that yourself. So, what I want you guys to do is I want one person from each table, and Mr. Winkle, you go ahead and pick the one person from each table. I want one person from each table to take the balloon, rub it on their hair really good, and have that can roll towards them. Okay? Just do that fun little experiment, and I want you guys to try it yourselves. All right, now that you guys have had a chance to move that can with the balloon, I want you to think, why could that balloon move the can or attract the can to it without pushing or blowing on it? It's not as hard as you might think. Take a look. I like to think of electricity like a magnet. You have a positive and a negative charge. Think of a magnet. When there's a positive and a negative charge, that's right, they attract. Okay. Now this attraction that they have causes them to get stuck together. Our can, for example, is a conductor. It is a positive charge. Our balloon created static electricity. It is a negative charge. Those two going together caused the can to be attracted to the balloon. All right, so now that you've had a little bit of time to investigate and study the positives and the negatives and how positives and negatives are attracted in electricity, let's talk about the flow of electricity a little bit so we can get into our experiment. The flow of electricity is kind of like a hose or a hose that carries water. Take a look. If I take and I have a hose like this one here, okay, the hose can only hold so much water. If I fill that hose up all the way, the water will spray out the end a lot. Okay, it'll go all over the place. If I have that same hose right here, the water slowly trickles out. It goes down slower. Electricity flows the same way. The way it flows in is called voltage. So let's draw this one here, a hose here, and a hose right here. Okay, same size. These aren't called hoses. They're called wires. Now when this wire is charged, it's called volts. So let's say this bad boy's got 120 volts. The 120 volts of electricity fills up that wire and goes out the other end because the positive is attracted to the negative. If this one only has 10 volts, it trickles out really lightly and only goes out a little bit. If you have something that needs a 120 volt charge, it's going to need every bit of that electricity flowing out. Just like if you had a sprinkler system or a hose and a sprinkler, you'd need all of this water to spray all over the lawn. You wouldn't need this little tiny bit of trickle right here. 10 volts can only power something really, really small. These are called volts. Okay, so volts is the amount of pressure that goes inside, the amount of potential difference that is in here. The other word is called amps, okay, or amperage. Okay, amps is the amount of energy or electricity that travels through it in a given time. For example, this one, if it had a little trickle of a charge going through, all the way through, and it trickled out, its amps would be lower, so would its volts. Now, this one, if it has a lot of energy traveling through in a specific given time, it has a higher amount of amps. So, amps, like this, is the amount of energy that travels through a wire in a given time, and volts, this word right here, volts, or voltage, is the amount of pressure that's applied in each one. Now that explains a lot. However, here's the thing. For us today, what we're going to be working on is the flow. So if it flows like water, we're going to use the same size wire, which has the same amount of amps and the same amount of volts. So we're going to try to get our voltage to travel in a complete circuit. Take a look. The batteries that are in here are producing an electrical charge. The electrical charge is only going through half of me, and it's floating midair in this hand. Well, that doesn't help us light this up. So what do you think I'm going to have to do with this hand to make this light up? Okay? Those are really good ideas. But here's the thing. All I have to do is touch it. It causes the electrical circuit to be completed. Very simply, the charge is traveling through me, out my other hand, and needs to be attached. Because if it's not, the charge is not being attracted in any way, because this one still is a charge, a negative charge. No positive charge being touched, so it's not being attracted. I have to have it be attracted. Make sense? If that makes sense, let's do our first experiment. you guys are going to be given a few wires, like this, or possibly more, a light bulb, which is tiny and small and very careful because it's made of glass, okay? A circuit board or an electrical panel, okay? And a battery. Now, your goal is to take your dry erase boards, just like this, and you're going to draw your circuit. You're going to show me how you can build a circuit that makes this light bulb light up using this battery and the wires you have. If you draw it, you will build it the same way you drew it. The team that finishes will then connect it to another team's to make all their light bulbs light up. Now, if your circuit board and your drawing don't match, that's okay. Adjust your circuit to match. Then what you're going to do is you're going to take and videotape the steps you took to get to that point. You're going to show me exactly how to solve your problem. Sound good? Okay, so let's go over it again. You're going to be given materials, some wires, a battery, a light bulb, and an electrical panel. You're going to make this light bulb light up using those electrical components. But you need to make sure you draw on your dry erase board the circuit and how you solved your problem before you build it. This is called a rough draft or a hypothesis, an educated guess. If your hypothesis is wrong, what do? You change it. Make sense? All right. Good luck. All right, so I saw some really, really good plans and really good designs for your huge circuits. And it was really great to see the whole class working together to get those light bulbs on. I am proud to see that you guys know now that electricity flows from a positive to a negative, and it's attracted just like a magnet and flows through that wire just like it's going through a hose. That electricity is just like what you see traveling through things like my iron's cable. You can see two different lines. It travels all the way through. You've got the positive end and the negative. They're attracted, meaning that they join together, and that they travel all the way in a circuit.